Welcome to a lesson on linear equations in standard form. In this video, we'll determine the standard form of a line from slope-intercept form, determine the equation of a line in standard form, and also graph a line in standard form. The standard form of a linear equation is ax plus by equals c, where a, b, and c must be integers, and normally the ax term is positive. Let's start by writing equations in standard form. So here we have point-slope form, and we want to rewrite this in standard form. So we'll first clear the parentheses. So I have y minus 5 equals negative 3x minus 12. So we know we need to have the x and the y terms on the left side and the constant on the right side. So let's go ahead and add 3x to both sides. So this would be 0. On the left side, we'd have 3x plus y minus 5 equals negative 12. We have one more step. We want to have the constant on the right, so now we'll add 5 to both sides. So negative 12 plus 5 would equal negative 7. So we have 3x plus y equals negative 7, and this is standard form. For number 2, we still have to have the x and y terms on the left side, so let's go ahead and subtract 2/3 x on both sides. So this would be 0. We'd be left with negative 2/3 x plus y equals 4. And there's two more things we have to deal with here. In standard form, a, b, and c cannot be fractions. It has to be an integer. So if we multiply every term by 3, it will eliminate this fraction. So let's go ahead and do that. Multiply the left side by 3, multiply the right side by 3. Well, 3 times negative 2/3 x will be negative 2x. 3 times y would be 3y. And 4 times 3 would be equal to 12. And then this would be okay, but normally the ax term is positive. So now we'll go ahead and just multiply both sides of the equation by negative 1. So we'll have 2x minus 3y equals negative 12. And this would be considered standard form. Now we want to take it one step further and find the equation of a line in standard form given the graph of the line. Now by now we know there's several ways to determine the equation of a line. Let's start by determining 2 points on the line we could use to determine the equation of the line. So for example, this point here would be the point 0, 2. This point here would have coordinates 1, negative 1. Let's start by putting the line in sloped-intercept form, meaning we want to find the slope and the y-intercept. We could find the slope of this line by using the equation y equals y2 minus y1 divided by x2 minus x1, but we could also just analyze the line. If we want to move from this point to this point, notice we have to go down 3 units and right 1 unit. Well, that tells us the slope is equal to negative 3 over 1, or just negative 3. Next, b is equal to the y-intercept, and we can see for this line, b is going to equal positive 2. So the equation in sloped-intercept form would be y equals negative 3x plus 2, and now we can just rewrite this in standard form. So we want the x and y terms on the left side of the equation. So let's go ahead and add 3x on both sides. Negative 3x plus 3x, that's 0. So we're left with 3x plus y equals 2. Now in this next question, we're given the equation of the line in standard form, and then we're asked to determine the slope and the y-intercept. So it's pretty much the opposite of what we just did on the previous screen. If we want to know the slope and the y-intercept, we need to rewrite this in sloped-intercept form, which means we need to take this equation here and solve it for y. So let's go ahead and subtract 2x on both sides. That would leave us with 3y equals negative 2x plus 9. And now we'll divide everything by 3, which will solve this equation for y. So we have y equals negative 2/3 x plus 3. So that tells us that our slope is equal to negative 2/3, and our y-intercept is equal to 3. So from this information, we should be able to graph the line where we plot the y-intercept as positive 3, And from the y-intercept, using the slope, we'll go down 2 units and right 3 units. So down 2, right 3, will be right here. And that's enough information to graph this line. Now there are several ways to graph a line, as we know. Now, as we already know, there are several methods to graph a line, but normally if a line is in standard form, finding the x and y intercepts is usually the quickest, easiest way. So let's go ahead and review that method. Remember that the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. To determine the x and y-intercepts, notice that any point on the x-axis has a y-coordinate of 0. So this should remind us that to find the x-intercept of an equation's graph, we replace y with 0 and solve for x. And notice that any point on the y-axis has an x-coordinate of 0, and therefore to find the y-intercept of a graph, we replace x with 0 and solve for y. Let's go ahead and give it a try. So essentially, in order to find the intercepts of this line, we are going to complete a t-table, but it's a special t-table. One point when the x-coordinate is 0, and the other point when the y-coordinate is 0. So to find the y-intercept, we set x equal to 0. Well, 4 times 0 would be 0, so we're left with a one-step equation to solve. We have negative 3y equals 12. Divide both sides by negative 3. So we have a y-intercept of negative 4. Now to find the x-intercept, we set y equal to 0. This would be 0, so we have 4x equals 12. Divide both sides by 4. We have x equals 3. So our x-intercept is the point 3, 0. Let's go ahead and plot these 2 points. Here's the x-intercept at 3, 0. Here's the y-intercept at 0, negative 4. And our line passes through those 2 points. So there's the graph of our line. Let's go ahead and try another one of those. Now we want to graph x plus 4y equals 8. Let's see if we can skip a step on this one. To find the y-intercept, we set x equal to 0. So if x equals 0, we'd have the equation 4y equals 8. So we divide by 4, and we have the y-intercept is equal to 2. Now to determine the x-intercept, we set y equal to 0. Well, if y is equal to 0, 4y would be 0. We'd have x equals 8. And those would be our intercepts. The x-intercept is 8, 0, right here on the edge. And the y-intercept is 0, 2, right here. And our line passes through those 2 points. Let's go ahead and finish by taking a look at a word problem that involves a linear equation in standard form. Manny has 2 part-time jobs. One job pays $10 per hour, and the other pays $16 per hour. He wants to earn $300 this week to fix his car. Write an equation that would describe this situation. Well, in this problem, we will have 2 variables because one will be the number of hours worked at the $10 rate, and another that will equal the number of hours worked at $16 per hour. So let's set x equal the number of hours worked at $10 per hour. Let's let y equal the number of hours worked at $16 per hour. So if Manny wants to earn $300 this week, if we multiply 10 times x, that would be the amount of money earned at the $10 rate, plus 16 times y. This would tell us how much money earned at the $16 rate. Remember, x and y represent the number of hours worked at each job. And for this week, he wants this to equal $300. So we have the rate times time plus the rate times the time must equal $300. Now we want to graph the equation that models the possible hours that could be worked at each job to earn $300. Remember, the equation was 10x plus 16y equals $300. Let's go ahead and graph this by finding the x and y intercepts. So we'll make a t-table, and when y is 0, we'll find the x-intercept, and when x is 0, we'll find the y-intercept. So when y is equal to 0, 16y would be 0, So we'd be left with 10x equals 300. So we'll divide both sides by 10, and our x-intercept is equal to 30. And then in order to find the y-intercept, we'll set x equal to 0. Well, when x is 0, this would be 0. We'd be left with 16y equals 300. We'll divide both sides by 16. I've already done this. It comes out to 18.75. And that would be our y-intercept. And before we graph these 2 points, let's go ahead and label our axes. Remember, the x-axis represents the number of hours worked at $10 per hour. And the y-axis represents the number of hours worked at $16 per hour. So our x-intercept would be 30, and our y-intercept is equal to 18.75, maybe somewhere right in here. So go ahead and connect these 2 points. So any point on this line represents a combination of hours that could be worked at either job to earn $300. And the last question is, if Manny is only allowed to work 10 hours at the job that pays $16 per hour, how many hours would he need to work at the other job? Well, remember, y represents the number of hours worked at $16 per hour. So in order to answer this question, we'd have the equation 10x plus 16 times 10 equals 300. So we'd have 10x plus 160 equals 300. And if we subtract 160 from both sides, we'd have 10x equals, well, 300 minus 160 would be 140. So dividing both sides by 10. And 140 divided by 10 would equal 14. So that would be 14 hours he would need to work at the job that paid $10 per hour if he worked 10 hours at the rate of $16 per hour. Okay, I hope you found this video helpful. Thank you for watching.